Hello everyone, welcome to part 2 of lecture 6. So in this lecture, in this part, we're going to talk about a few properties regarding the derivative. So first one, so first one is the called constant multiple property. So meaning when there was a constant that multiplies the function u of x, then when we are taking the derivative of this function, then the k is actually stay the same. It follows the derivative u prime of x, right? So we can express this form and this form. So basically, if there's a constant, then it stays there. It's not changed. Okay, so now let's look at one example. So here we have this example f of x equals 3 times x squared. Now, when we have this, then the derivative can be calculated as 3 times the derivative of this one, right? Becomes 3 because now 3 stays the same. So it can be 2x becomes 6 times x, right? So basically this is just follows. If there's a constant, that constant stays the same. All right, so next one we have the sum and difference property. So what this means is that if function f of x is itself consists of the sum or the difference between two functions u and v, then we can actually apply the derivative operation in each of the function u and v, and this summation and difference in the operation stays the same, right? So basically, we just do the derivative operation in each component of the function, right? So we can express it in this way as well, or in this way. Okay, so let's look at this example. So f of x becomes these two parts. Then if we take this derivative, we have, so the first part, according to the previous example, we have 6x as a derivative. The second one is going to be 2. So basically that's a 2 times x, right? So x becomes, the derivative of x becomes 1, right? Becomes 1. Or you can say that's the derivative of x, because x is equal to x to the power of 1. Then we take the derivative of x becomes, this is still a power function. So we're moving 1 besides, x to the power of 1 minus 1, right? Becomes 1 times x to the power of 0. So anything that's to the power of 0 becomes 1. So this becomes 1, right? So now this is the results we have for the difference, for the derivative of this function. Okay, so next we have the product rule. So when x becomes the product of two individual functions, then the way we calculate the derivative of f of x becomes, we actually spreading the derivative operation to each of the individual function and add the results together. So what we mean by each of the individual functions. So first we apply the derivative to get s prime of x, right? And then still times f of x, uppercase. Now, next we take the derivative of the next function and then times the first function, and then these two add together. So, this is a series of operations chained together, right? So we can express this in this form or in this form. So basically, if they are if two functions multiply together to get the function f of x, then we need to distribute the derivative operation to each of them separately, and then adds the results together. All right, so this is how can get results. When we look at this function, so this function itself consists of two parts: the first part, and then the second part. Alternatively, so this is where we can plug in using the formula. Alternatively, we can say we just multiply. So if we multiply, it becomes f of x becomes 6x to the power of 6, right? 2 plus 4. Multiply 4 times x to the power of 2. Now, this becomes easier. then we can actually apply the usual formula and get the results. But it's it's using another rule. Now, for this example, we need to use the rule, which is a product rule, to get the results, right? So that's where we can plug in the formula. Okay, lastly, we have the so-called quotient rule. So quotient rule studies this form. What if we have a quotient that consists of two functions, the numerator, the function t of x, the denominator function b of x. So this can be considered as the most complicated case, right? But still, there's a formula to calculate that. And with the formula, we just plug in and we get results. So the formula is that what happens to the denominator, it becomes the square of the function of b, right? So b square, right? That stays. The top numerator, it becomes something like this. So we first take the derivative to the function of t, right, multiplied by b. So this is the first part. The second part is then we take derivative to the function b, then multiply function t, and then we minus off these two terms. And this part has to stay comes first. So we take the derivative to the function t first, then minus off the second part. So cannot cannot take the derivative to b in the first place, right? So the sequence is very important. So this is basically the formula, and we have the simplified notation here. We can express it here. So basically now this is the derivative to t first, then the derivative to function b. Then again, the denominator is the square of function b. Right. So with that in mind, with this function, we can just use the formula, plug in, and get our results. So for example, we start with the denominator, which is 2x minus 1 square, and then we first take the derivative of x square, right? And then we need to multiply 2x minus 1. So it doesn't matter if it appears before or after the derivative, minus the we need to take the derivative of so now let me write this first, x squared times 2x minus 1 derivative, right? So now we can apply the derivative to each of them and simplify the terms, then we get the results. Right, so that's going to be an in-class access, by the way. Right, so that's it for today's class, and thank you for watching. I hope to see you in the next lecture.